Hi, I hope everybody can hear me okay. Um, we're going to be looking at lesson 3.2, exploring linear relations right now. We're going to be going through and explore the math from the textbook, starting on page 150, and I'll call that up for you right now, just to show you what that looks like. Okay, so here's the page that we're going to be looking at. A few things for us to do here. So it's going to ask us to, or it tells us first that Rana's computer repair service charges $45 an hour. Bill's computer repair service charges a flat fee of $25 plus $18 per hour. And we want to compare both of these. So we want to see how the plans are alike and how they're different. So we want to make a table of values to show solutions for each company's cost for 0, 1, 2, and 3 hours of service. So what I'd like you to do is set up two tables of value where the left-hand column of each would be the number of hours of service and number them vertically down 0, 1, 2, and 3 on the independent rows afterwards. And then in the right-hand column, calculate for each of these repair services, Rana's and Bill's, how much they would be charging the client for 0 hours of service, 1 hour of service, 2 hours, etc. Okay, so please pause the video and set up your tables of value, so then you can find those values, and then we'll take a look in a second what they look like. Okay, so pause your video now and do this independent work now, please. Okay, so if I can ask you to look up here, I'm not sure if I can, no, or maybe not in here. If you can take a look up at the top here in the upper left, we see this is Rana's repair service. So X1, X represents the left-hand column, which is the number of hours of service. And we've got 0, 1, 2, 3, 4 hours of service on each of the independent rows. And then on the right-hand column, we've got the total charge, or the total cost that Rana will charge the client. And here we've got 0. For 0 hours of service, they're charging nothing, because if they're not doing anything, they're not going to charge anything, because Rana only charges $45 per hour. And then after 1 hour, she charges $45. After 2 hours is $90, 3 hours is $135, and after 4 hours is $180. Now when we go down here and look at Bill's table of value for his charges, again, the left-hand column is the number of hours worked. The right-hand column is the amount that he charges. So he was charging $25 plus $18 per hour. So the $25 would be what's called a flat fee, or maybe a service call fee or something like that, just to show up to the house if it's going to be a house call. And so even before working any hours at all, they work zero hours, they still are going to be charging the client $25. After charging working 1 hour, they charge $43 in total. After working 2 hours, they would have charged $61 in total. After 3 hours of work, they charge $79 in total. So if you would take a look at this from 25 to 43, well, there's the $18 per hour that Bill is charging for his work. And then from $43 to $61, there's another $18. So that's for the second hour of work. For the third hour of work, there's another $18 that he's charging, going from 61 to 79. So notice that the change here between each row is $18. But this one, for Bill's, it starts at 25, and that's matched up with 0 hours of work. Whereas if we look up at the top for Rana's table of value, she each of the changes from 1 hour to the next of amount of work is charging $45. So the change is $45 in each of these rows, but it's starting at 0. Okay, so now after the table of values, you were asked to plot these graphs. So here's the graph. If we take a look over here in the grid, we see down at the bottom, right at the origin, 0, 0 is where the first point is, and then 1 and 45 is the second point right here, 1 and 45. And then if we look over here, we've got 2 and 90. So 2 and 90 matches up with this point here. 3 and 135, if we come across to 3 hours and then up to $135, there's that fourth point. And then the fifth point is 4 hours and $180. So we're starting at the origin, we go across 4 hours, and then we go up to $180. Okay, so that's what the graph looks like for Rana's service. And then I guess I'll go, no, I won't go back just yet. Here we'll now plot the graph of Bill's repair service. So at $0, he's charging $25. Sorry, 0 hours of work, $25. So 0 hours, and we go up 0 hours. So along the x-axis is the number of hours. 0 hours is $25, and then 1 hour of work, he'll charge $43. So 1 hour, we come across to 1 hour, up to this red dot, which is $43. 2 and 61, so we come across from 0 to 2 hours, up to $61. 3 and 79 match up, so 3 hours of work goes up to $79, and then 4 hours of work, and that matches with $97. Okay, so those are the two scatter plots. Now let's kind of see what else we're asked to do here. And I'll just come over here to this. Okay, so back to the textbook. So it says graph the relation between cost and number of hours of service. How are the graphs alike and how are they different? Use an equation to describe the cost in terms of hours of service. So we'll go back to that in a second, and how the equations alike and how are they different. Okay, so let's go back now to the graphs, and we see, well, let's take a look at how are they the same. So if we take a look at the green points, the scatter plot of green points, which is Rana's charge, or her cost for services for computer repairs for each hour. How does this compare, if you take the general trend of those points, compared to Bill's? How are they the same? Well, notice if you go from 0 hours to 1 to 2, as you increase the number of hours, we see that the cost is also increasing. Okay, and that's the same for Rana's, which is higher. And Bill's, as you increase the number of hours, his cost is also increasing. Okay, so both of them are increasing in the cost. So as you increase in the independent variable, which is along the x-axis, you're also going to increase in the dependent variable in the y-axis. And how are they different? Well, one way we can see they're different is Rana's graph, or her scatter plot, starts at 0, right at the origin, as it progresses up. And Bill's does not start at the origin, it starts at 0 and 25. Okay, so it's starting higher up on the y-axis than does Rana's. Okay, we're going to go back here now. I'm going to go back to the worksheet for a second, and we'll take a look here. I'll look at these in a second, the direct variation and partial variation in a second. What I want to do, though, is I want to, oops, I didn't want to do that. There we go. I want to do this. Why is this not moving? That's interesting. I'm trying to move this. but it does not want to move for me. And I don't know why. I'll have to scroll. There we go. Okay. So we're going to look at the equations now. And so we want to write the word equation for each. So Rana's cost. Well, what does Rana's cost entail? Well, we know that she charges $45 per hour. So we could just say $45 per hour of work. Now, generally in equations, we don't use units. So in the next section here, the algebraic equation, we won't include that dollar sign. And then for Bill's cost, there we go, let's change it to blue. So Bill is charging $25 plus an additional, on top of that, he's charging $18 per hour. Okay. Now, so if we wanted to take a look at this in an algebraic sense, $45 per hour. So remember that if we know Ron is charging $45 and it's for every hour worked. Well, we don't know how many hours she's going to work, so that's an unknown. But notice if we go back to this table of values here, look over here, we see that for 0 hours, she collects $0, or she charges $0. For 1 hour, she charges $45. For 2, it's 90. For 3, it's 135. So we know that the difference between each of these is $45. However, if we wanted to jump, instead of counting up 45s, like by adding 45s each time, we could say, well, how much does he charge for 4 hours work? Well, instead of counting and adding 45 4 times, well, that could give it away right there, we could actually multiply 4 times 45. So if we go back here, if we're charging $45 per hour, then and to get a higher number of hours, the charge for a higher number of hours, we can say it's 45 times or multiplied by h, which in this case would be the number of hours, okay, or 45h. So you can use a dot for multiplication, or you don't really need to either. You can just say 45h. Okay, so that's 45 multiplied by the number of hours, which you don't know, so that's the variable. We're not sure how many hours Ron is actually going to be working there. And then for Bill, well, he starts off with $25, so he's got the service charge, $25, plus an additional $18 per hour. Okay, so $18 multiplied by the number of hours he works. Okay, so that would be the 18h. So you could substitute in different values of h in here, and then we could multiply 18 multiplied by the number of hours, and then add the 25 at the end, because we're still using GEDMAS, we're still using order of operations, and we want to see how much the total charge would be that Bill would charge. Okay, so that's how we would form the algebraic equations from these word equations. And if we look at the table of values, we've already sort of gone through that. I went up to 4 hours, but that's okay. We knew that we looked at the hours going up one at a time. So in what's called the discrete manner, we're counting up by ones. And the cost for Rana was going up by 45. And then for Bill, the cost was going up by 18, even though his started at 25. Okay. Now let's see here if I can scroll again here. Can we do this? No, not with the pen, I can't. Okay, so we have these equations. I'm now going to come back over to the graph, and I'm going to look at the equations now. So we already noticed on the other side, on the other page, that we had C equals 45H. Well, if we change the C to Y, because the cost is in the vertical, the dependent axis, and the number of hours is in the horizontal, the independent axis, which is also the X, the equation would be Y equals 45X instead of C equals 45H. And then for Bill, his equation was C equals 25 plus 18H. We can now change that to Y equals 25 plus 18X, because Y represents the vertical axis, which is the cost axis in dollars, and X represents the hours, the number of hours worked in the horizontal or the independent axis. So his equation then would be Y equals 25 plus 18X. So now if we were to draw the line through, now we just draw one straight line all the way through. Now, luckily, because these come from an equation, all the points line up perfectly. So if I drew a line here, we would see that they go through all the points perfectly. If it was a random scatter plot that we were using experimental data with, chances are not all the points would line up perfectly. But because they come from an equation, they do. And so that's the equation for, that's the line for Rana's graph. And then we can do the same thing for Bill's graph. Will be going like this through all the red points. Okay. Notice that for Bill's graph, we've got this 0.25, which we notice is from the table of values, 0.25. That's where the graph crosses that vertical axis. That's what we call the y-intercept, because this line crosses the graph, which is this line. The graph crosses the vertical axis at 0.25. 0 units horizontally and 25 units vertically, and which corresponds with 0 hours worked and $25 charged. If we look at Rana's, we see that her intercept, the y-intercept, is actually 0, 0. It goes actually right through the origin. So we can find that that's the amount of hours worked and the amount charged. And one other interesting thing that we'll take a look at in more detail later, if we take a look here, we notice that we've got 0.926 and 41.667, which is that point right there. And notice that that point is where these two graphs cross, which is called actually a point of intersection. And again, we'll get into that a little bit later. And that 0.926, what does that correspond to in terms of our number of hours worked and our cost, the amount charged for their service? So the X value, the first value, is actually 0.926 hours. Now, it didn't work out perfectly. I could have changed, and maybe in other ones we'll change one of these values so it actually intersects a little bit nicer than this. But 0.926 is 0.926 hours, and 41.667, that's the number of the amount of money charged for each of those services. So because they both intersect at the same point, that point is actually on both graphs. So because both lines intersect at the same point, that point is actually on both graphs, which means that if you hired Bill to repair your computer, he would charge $41.67 roughly after 0.926 hours of work. If you chose Rana, we would notice that she would charge $41.67 for 0.926 hours worked. So right at that point in time, it doesn't matter which of the two services you select, they're going to charge the same amount of money. Okay, and we'll analyze this kind of thing a little bit more in detail in the future. Looking at, if a repair was less amount of time than this, which one would be cheaper? And if the repair is greater than this amount of time, which one would be cheaper? Okay, so we'll take a look at that also in the future. All right, so let's go back to the handout. And so we looked at a couple of things here. There's a couple of definitions, and these definitions actually are found in your textbook, and they are in the margin here on this page, on page 150. So we see the y-intercept, which I've mentioned. That's the value of the dependent variable when the independent variable is 0, sometimes called the initial value. I've been talking about a service fee or a fixed fee, maybe a service call to the person's house. So when the independent variable is 0, so in this case, when the number of hours is 0, the y-intercept is the amount that's being charged by the different computer repair services. So that's one thing we mentioned. Now, one thing that I haven't talked about yet is direct variation. And the direct variation is a relation in which one variable is a multiple of the other. Okay? And if it's a multiple of the other, like a perfect multiple of the other, then when we take a look at this, we see that Rana's, the repair cost that Rana would use to calculate the charges would be 45 multiplied by h. There's nothing else in this equation. It's just 45 times h. So anytime you multiply this value in front by whatever value you substitute in for h, that's a multiple. So 45 times 0 is 0. 45 times 1 is 45. 45 times 2 is 90. So 0, 45, 90, 135, etc. Those are all multiples of 45. Okay, and that's just as simple as it gets there. Then if you look at the partial variation is a relation in which one variable is a multiple of the other plus a constant amount. So if we go back to our equation here, to Bill's computer repair service, we've got a multiple here, 18h, plus a constant amount. That constant is 25. So remember that a variable is like a letter that we use for variables, and that value can change from question to question and from instant to instant. But the 25, that's a constant because that 25 will always be 25. So that's constant. Okay, so this Rana's repair, that equation is direct variation because it varies, the cost varies directly with the number of hours that are worked. For Bill's is partial variation because his charges vary partially with the number of hours worked and the constant amount that's added on there. Okay, and so when you look at the equations, we can see that they have a certain form, one being direct variation and one being partial. Then if I look back here at the graph, then we look at the table of values. Well, Rana's was direct variation, and so we've got a 0, 0 in her table of values, whereas in Bill's table of values, we got 0, 25. Okay, so that's not 0, 0. So if it's 0, 0 in the table of values, that's partial variation. Sorry, I correct myself. That's direct variation. And if we have 0, 25, that's partial variation. Okay, and then if we go a little bit, one step further and go to the graph, in Bill's graph, if we look at Bill's graph here, his y-intercept, the y-intercept of the graph for the charges of his repair service is not going through the origin. It has a a value different than 0. Okay, so at the number of hours is 0, that's the x value. The y value, or the charge, is not 0, it's 25. Okay, so that matches with the table of values of 0, 25. So the y-intercept for Bill's repair service, for the graph of Bill's repair service, that is not going through the origin. Okay, so it has a y value, or an initial value, that's not 0. If we look at Rana's graph, Rana's graph goes through the origin, okay, and we know that her graph, we looked at this, is direct variation. In the table of values, it's got a ordered pair of 0, 0, and on the graph it goes to the origin. Okay, so the independent variable, 0, the x, the number of hours, matches up with 0 cost. So the dependent variable is also 0. Okay, so those are 3 different ways to determine whether it's direct or partial variation. Direct variation has a graph that goes to the origin, and the table of values that has 0, 0, and the equation that is just a multiple. Okay, all these things match up together. Then partial variation, we've got a graph that has a y-intercept that's not 0, matches up in the table of values with the ordered pair 0 and some other number that's not 0. And the equation is some constant added to some multiple term. Okay, so I think we're getting to the end of this worksheet here. Okay, what distinguishes the 2 costs? What part of the graph indicates the difference? So there's a couple things that we looked at. Now, I noticed the word here, rate triangle. Rate indicates rate of change. And the rate of change, and maybe I'll go to a whiteboard for a second. Not sure if this will work out all that well, but we'll give it a try. So here's a whiteboard, and I'm going to draw, well, do I actually have a grid? Is that a grid I can use? I'm hoping. Well, it doesn't seem like much of a grid. Okay, anyways, so I'm going to now actually select this and get rid of that now. Okay, so if we have table of value, or 2 axes, we had one graph that was like this. It was through, sorry, it was through the origin. Now, if we were to examine this, and we looked at the amount that the graph increased for every amount that the graph kind of moves to the right, or for every step we go along the x-axis, we see that the graph increases a certain amount. So this, what I've drawn there, that is actually called a rate triangle. Okay, so it's talking about the rate of change of cost. Okay, the rate, in this case, is the rate of change of cost. Change of cost. And so that triangle is the rate triangle, where the line itself, the graph itself, is the hypotenuse, and we add in the 2 legs, which show the the fact that it's a right triangle. So we're going perfectly vertical in one direction, like along the dependent axis, perfectly horizontal in the direction of the independent axis, and where those things match up and join the graph itself, that forms the rate triangle, which tells us the rate of change of cost. So for every hour that we that the workers are there working, for every hour, let's say this is 1 hour, then we know that for Rana, at least, it's $45 increase. And there's 1 hour of work. Okay. Again, we'll explore this a little bit more. So there's the rate triangle for Rana's graph. And I'll just quickly do Bill's graph. We know Bill's does not start at 0. It goes something along that line, pardon the pun. And use orange. So for Bill's, and you know what? Do I want to do it in the same space? No. I'm going to go over here and just say I'm going to start at the 1 hour mark. And I'm going to go up. And then I'm going to go across like this. This is not the perfect example, of course. But let's say we go to 2 hours and then 3 hours. Well, from 1 hour to 3 hours, there's a 2 hour change. And the cost, well, his value is increasing every $18 for every 1 hour. But over 2 hours is actually $36. Sorry about that. So that should be 36. So for 2 hours work, his graph is increasing 36. So the rate of change, again, so it's 36 for every 2 hours, which is the same as $18 for 1 hour. Okay, so that's what we talk about that's what we mean by talking about rate of change. Okay, and let's see, is there anything else we want to look at here? Show the rate of change. I think that's sort of all we're going through. So so if you can kind of use the summary that's on the in the textbook that you see right here. For direct variation, partial variation, we see in the in summary box here on page 151, you can see the differences between direct variation and partial variation for the table of values, the graph, and the equation. Okay, so that could be something that you could fill out here in your note just to kind of complete this. Okay, so that's pretty much it for graphing, going from a table of values or from a word equation to a real algebraic equation to a table of values to a graph. So all those things are all related to each other. We've touched on rate of triangle, which we'll get back to again. And if you can fill out direct variation, partial variation from that summary box in your textbook, and then take a look at these homework questions at the bottom of the page here, number 1, C to F, number 2 and number 3. If you can work on those, that would be just terrific. So thank you very much for watching, and we will see you again.